Determine given reasons the size of the following angles: B2, B1, and A2. Let's go through the question statement and see what information we can extract. In the diagram below, the circle passes through points A, B, C, D, and G. Right. AD is the diameter of the circle. BD and AC intersect at H. Angle AGC is equals to 58 degrees. So the interesting things here is that AD is a diameter. So let's go ahead and highlight that. Right. Why are we highlighting the diameter? Because we know fully well that the angle it subtends at the circumference of the circle is 90 degrees. Right. So that is AD, that is the diameter. A, B, C, D, and G are points that lie on the circumference of the circle. So those points, well, A, B, rather, let me highlight that. A, B, C, G, that should be a cyclic quad because they lie on the circumference of the circle, right? The same is true with A, B, D, G. That should also be a cyclic quad. But anyway, let's take a look at our questions and see how we can answer them. 8.1.1, we are looking for the size of angle B2. This is angle B2 right here. It should be quite easy to see that angle B2 is being subtended by AD, right? So we can say that angle B2 is equals to 90 degrees. It is subtended by a diameter. It is subtended by a diameter, right? So that's how easy 8.1.1 is. And then 8.1.2, on the other hand, we want to find the size of angle B1. So we have B2 right there, and then here's angle B1. Right. So you should realize fairly quick that angle G, this one right here, which is 58 degrees, should be, when we add it to B2 and B1, that should give us 180 degrees. Those are the sum of the opposite angles of a cyclic quad. So what are we saying? We're saying that angle AGC plus angle B1 plus angle B2 should give us 180 degrees. Right, that is the sum of the opposite angles of a cyclic quad. Right, so we have to give that reason. Sum of opposite angles of a cyclic quad. Right, we know fully well that ABCG is a cyclic quad. What is the size of angle AGC? That is 58 degrees. Well, that looks like 88. So that is 58 degrees. Plus B1, that's what you're interested in. And then plus B2. B2 is 90 degrees. This is equals to 180 degrees. So we have 58 plus B1 being equals to 90, right? I just said 180 minus 90. So B1 is equals to 90 minus 58, which is 32 degrees. So there we go. This is the size of angle B1. Let's take a look at A2. 8.1.3. We're looking for the size of angle A2. So let me just erase a few things so that we can have a bit of clarity. Right. So we know that B2 is 90. Let me just denote it like that. And we know that B1 is 32. Here we have 32. Right. What are we looking for? We are looking for A2. A2 is this angle right here. A2 is this angle right here. Okay. So of what we have calculated already, what can we relate to A2? What can we relate to A2? Let's start by taking a look at B2. Is there a way we can relate A2 to B2? Well, A2 and B2, they can be some, not some as in SUM, but SOME. They can be some of the angles on the triangle ABD, right? But that seems a bit far-fetched because we don't have the size of this triangle, of that angle. We don't have the size of this entire angle. We just have this 90. So it seems a bit far-fetched. Let's explore B1 and see how we can relate A2 and B1. Okay, so B1 is subtended by the arc DC, right? The arc DC, yes, the arc DC. Yeah, it is the one that is subtending B1. But that same arc, it also subtends A2. So A2 and B2 should be close to each other. So we can say that A2 is equals to B2, right? Angles in the same segment. Angles in the same segment, right? So A2 is also equals to 32 degrees. Okay, so there we go. We can say that A2 is equals to B1 because of that.